morning. I'm going to try and explain integration to you this morning for those of you who weren't able to make it into school on Friday. So integration is chapter 13 and it's the opposite of differentiation. That's the first thing, that's the really, really important thing. So it's the opposite of differentiation. I think the easiest thing to do is to actually start by differentiating something and then we'll go backwards again to see what we get. So let's say that y equals 7x squared plus 4 root x plus 7. So that's our function, and I think we'll start with this. What we'll do is we'll differentiate it and then we'll integrate it again, and we should hopefully get back to what we started with. Okay, so remember, for differentiation we write dy by dx. So I've got dy by dx equals, so multiply by the power and reduce the power by 1. Now what I should have done before I started, which you've probably done I would imagine, is to write that square root of x as an x to the power of a half. So I haven't done anything in this step, but I've written it in such a way that now I'm able to differentiate. So I've differentiated this bit, done the 2 times 7 and decreased the power. Now I'm differentiating this bit. So I do 4 times a half, and then I decrease the power. So I was on a half, so I take away 1, now I'm on minus a half. And then when I differentiate the 7, it just goes. You can imagine at the minute I've got an x to the power 0, so when I times by 0, that goes. So that's what I get when I differentiate. So now, if I were to integrate this, well, let's see what we would get. So now I'm going to integrate this, and we'll learn in a minute how to write that I'm integrating. But for now, let's just say that we're going to integrate this. So I would get 14. Now, before I multiplied by the power and then decreased the power. So I'm going to increase the power and then I'm going to divide by the new power. So it is the exact opposite of what we did before. So before we multiplied and decreased the power. For integrating, you increase and then divide by the new power. That's really important. So increase power, divide by the new power. Now, I find it quite nice to remember that differentiation starts with a D for decrease, integration starts with an I for increase. So now let's do this one. I always leave this number alone in my first line. So I increase the power. So I was on minus a half, so I add 1 to the power and then I divide by the new power. Now the eagle-eyed among you is going to spot that in my original I had a number. When I differentiate, that number disappears. When I integrate again, I've got no way of knowing at the minute what that number was. So for integration, when we integrate, we always put a plus c. And that c just represents any number that we might have lost when we differentiated. Right, so let's tidy this up. So I've got 14 divided by 2, which is 7. I've got 2 divided by a half, which is 4. And I've got a plus c on the end. It's really, really important that you remember that plus c. Okay, so that's kind of a little introduction. In the next video, I'll talk about how we denote it and the difference between definite and indefinite integrals.